Okay, in example 4, we're going to interpret a drawing that's a little bit complicated looking at first, but it's not too bad. So, referring to the figure, how many planes appear in this figure? Well, before we get the number, let's just go through and identify all of them. We can see clearly there's plane P, right? So that's the name of the flat rectangular plane. It's kind of horizontal in this picture. There's also plane CAG. So which one is that? From C to A to G. So that triangle that's kind of in the background of this cone shape, that triangle is its own plane, right? We could put that triangle on a piece of paper. That piece of paper would not be facing in the same way as this plane P. Okay, it would be its own plane. So plane CAG. Plane GFA is GFA, the other one in the back, the other triangle in the back that exists on its own plane. Plane, well, it's going to be the three other triangles, right? The front one on the right, the front one in the middle, and the front one on the left. So triangle FAE, EAD, and DAC would all be describing their own planes. Let's zoom in a little bit on that so we can write that. Okay, so to say that again, that would be points FAE, EAD, and DAC. Now remember the order of those three letters doesn't matter. I could have said ACD, CDA, whatever I want. Okay, so there are 6 total in that picture. Okay, 1 for the big flat one, 5 for the 5 other surfaces that are not part of that horizontal flat surface. Okay, now we want to name 4 points that are collinear. So what 4 points are collinear? Well, we're given 2, H and I, so we're doing H and I. What other 2 points are along line HI? Which other ones are collinear to those points? It would be C and F, right? Just the ones that are in a straight line. Okay, how about we name the intersection of plane GAC and plane P? So which one was GAC? Well, GAC was G in the back, A up top, C on the left, so it's this back triangle, and plane P. Well, where do those two intersect? The only place where you get both of those planes being represented is from C to G, right? That is in plane GAC. GAC, it's in that plane. It's also in plane P. And as we said before, the intersection of 2 planes just gives us a line. So it gives us the line CG. Okay, last one for that figure. At what points do JI and DC intersect? So JI and DC. Nope, not for that picture, I guess. Am I correct to say that? Let me scroll up. JI, nope, it was the first picture. So JI and DC, at what point do they intersect? I don't think they do. So JI right here going straight up and down, DC going right, going in this direction. Okay, those do not appear to intersect with each other at all. If they did intersect, they'd intersect at a single point. However, they don't appear to intersect at all. So I think what we're looking for is the word not. It does not appear that these lines intersect. DC lines in plane P, but only point, I think it was I, the bottom one, point I of JI lies in plane P. Okay, so since only one point was there, you're not going to get that intersection. Actually, I would say because they're not overlapping in any way, you're not going to get that intersection. I'm not sure that really matters that only point I lays in that plane. You could have point I in that plane if we shifted this vertical line over, so it crossed over, okay, so that I was on the same point as C. Well, we wouldn't have any problem. There'd be an intersection. But the real problem is that they don't overlap in any way. So there is no intersection. Okay, so let's look at this very last part, which is to refer to the figure and say we want to name 3 points that are collinear. So 3 points that are collinear, the only 3 that I see are A, D, and B. Okay, I looks like it might be on this line, but it's not really included in it, so we're not sure for 100%, but A, D, and B look pretty good there. A, D, and B. Okay. Just going to read 2 little notes on the side of the page here real quick. Okay, the first one being that just a reminder that a point has no dimension, right? It doesn't have a length, width, or height. A line exists in only one dimension. The length of that line is the only dimension it exists on. It doesn't have a width. It's not a thick line. Okay, so the definition of a line means just a straight line between 2 points with no width or height, just one dimension. A circle is 2-dimensional because it can exist on a 2-dimensional piece of paper, and a pyramid like this is 3-dimensional. Sure. 3-dimensional drawings, because it is impossible to show an entire plane in a figure, edge shapes with different shades of color are used to represent planes. So they're saying that, like, in the same way that this line goes on forever and ever in the direction the arrows points, but we're not going to draw forever and ever, so we just draw the arrows. Same thing on these planes. These planes extend forever and ever, so it's like an infinitely big sheet of paper, but we can't draw that, and we don't really want to draw a bunch of arrows coming off the corners or something. So we just draw edges, and we understand that those edges are just kind of representing the inability to really draw the plane as we define it. And instead, we just draw it kind of in a simple way that models the idea.